Welcome to the WAGAS Innovation Talks. This podcast offers you an insight into recent innovations in the tech business, driven by research and industry insight. We are talking to researchers and professionals to share their expertise, experience, and projects with us. As a think tank and accelerator, we support tech startups and corporations in growing their business. We believe innovation is key to growth and hope to shine light on academic research and experts with real-life industry experience. To learn more, visit wagas-group.com and find all our podcast episodes plus articles and resources to expand your horizon on tech innovations. My name is Livia van Herde. I am the Marketing and Sales Manager at WAGAS, and today we had the honor to welcome Fabrizio Boer to the podcast. Fabrizio has a background in mechanical engineering. He earned his master's degree from Polytechnic of Turin in aeronautical engineering and flight mechanics. His career experience includes senior mechanical engineer for Paggio Aerospace. He held the same post at Antwerp Aerospace. Alenia AirNSpace had him as senior operations engineer. Time at GSM Aerospace saw him return to mechanical engineer. He also sat on the European Commission as an Independent Expert Evaluator. Fabrizio is now the Chief Mechanical Officer for GSM Automotive in the UK, where he is currently based. Recently, he transitioned to both Chief Technical Officer and Director of ShipNSpace. Welcome to the podcast, Fabrizio.
Thank you very much for the invitation.
Today's episode is about space technology. And to start off, let's address a topic that I think a lot of people have been wondering about when it comes to space projects. How come space projects are now private and are taking over the market? Isn't it too expensive? What happened to the government space projects? Can you give us an overview?
Well, up to about 10 years ago, it was believed by the larger public that only space agencies like NASA or ESA could finance space launch missions.
Right.
However, skilled engineers like, I guess myself, working for larger space companies like Thales, Alenia Space, or Airbus, have always had the awareness that it could be possible to make a space launch mission spending much less money than government agencies did. The reason was that up to about 10 years ago, space was basically a protected market, and larger space companies could basically profit of this monopoly by applying unrealistic number of expensive working hours and developing utterly expensive subsystem units sold as brand new when just a few modifications were made. So, when brave entrepreneurs such as Elon Musk or Jeff Bezos started to set up their own business, thanks to their obviously consistent financial sources, and were surrounded by a rather low number of skilled engineers compared to larger companies, but demonstrating to be successful while spending a fraction of the space agency money. Space business has started to change, and larger companies like Boeing, for example, not prepared to face these new price challenges, have lost most part of their competitiveness, and also I think credibility, as today nobody can believe that something developed by Boeing and sold to NASA at 3 times the price made by SpaceX, for example, is more effective. So in a few occasions, it has been proved that the other way around. So the point is that it is possible to be successful in the space business by just doing what is necessary to do, by applying a smart design principle, reducing unnecessary design constraints, such as fatigue in mechanical components, something that is, unavoidable for continuous operating aircraft along 20 years lifespan, but they are barely applicable to a 20 minutes space launch mission, in which once you are on orbit, either the mission is over or the loads do not change anymore or are negligible. Yeah.
All right. And how does it work to build up such big projects?
Well, when you deal with a complex systems such as, for example, a suborbital vehicle or a launcher, it is effective to start with high-level requirements, such as the number of passengers, the altitude to be reached, the safety figure that you intend to get, the mission's occurrence per month or year, and start to find a suitable architecture able to satisfy all these major requirements that can, be less than 10. The project is then divided in 5 phases: phase A or feasibility phase, phase B or development phase, up to a milestone called PDR, preliminary design review, where the general architecture is modeled in 3D CAD and finite element modeling or FEM analysis is made. Phase C, which includes the critical design review or CDR, milestone in which the manufacturing drawings are frozen and manufacturing can finally start. Then we have phase D, that is coincident with the assembly and testing of the system components until the overall qualification of the system is got. And phase E, where the real operation can start after the flight readiness review is positively accomplished. So if you are an aerospace engineer with a mature background in mechanical structural design of primary structures, you can start to design the main components, such as the passenger cabin, and accommodate it in a 3D layout that will permit you to host all the passengers' number. And when you are doing this exercise, you must consider how to keep the parts together inside the fuselage and the fairing, and how to structurally interface the different components, such as how to fix the wings to the fuselage or the tanks inside the fuselage. When a 3D model is made about the whole vehicle architecture, you're ready to accomplish studies in terms of mass, FEM analysis, performance, or cost. So when the general architecture is ready, you split the main subsystems and try to identify the potential suppliers for each major component. So at this stage, you can prepare a development plan in which development time and cost is estimated for each subsystems item. And once the component specifications in terms of concept, drawing, size, material, performance is accomplished, you can send it to the potential suppliers to ask to quote against. And from their feedback, you decide to bid them or not for its development. And then, qualification plan is then prepared to identify all the possible tests that are needed to qualify the whole systems. That is what is all about for the whole process.
And what are the hurdles of private space projects? What can happen?
Well, our mailing of financial order. The problem of a private startup with no initial financial sources is to find the necessary budget to build up at least the engineering team to provide the initial feasibility assessment, performance, and cost analysis, and prepare a business plan. At this stage, without any budget, it is very difficult to even opening a dialogue with the potential partners or suppliers, because there is no activity that can be committed without a budget.
Right.
So most part of the activities are made in spare time because the startup core team has very often the necessity to get money for their families out
Mm,
of another job, as it has been my case.
mm,
Startup in these conditions can survive only if the experience of the team is large enough to progress in the activities by adopting design solutions that are known to be working by past experience results. Preliminary hand calculations permitted to get a rough idea of the performance that can be obtained without needing sophisticated and expensive programmed analysis.
mm,
More critical, I think, is the situation in which the core team comes from the same background, likely
mm,
technical, as it has been my case, unfortunately,
mm,
which means that from that technical viewpoint, it looks perfect, very good, but is totally missing or very poor from the financial, sales, or marketing viewpoint, uh, because there are no expertise on that. Yes, the orders, I think, are almost infinite for a startup
mm.
without any initial money, and only the perseverance and guess the determination of the founder can permit it to survive.
Right, I see. And let's talk about something a little bit more positive. What do you personally think were the latest breakthroughs in space technology the last couple of years?
Uh, I think the main breakthrough of, let's say, 2021, 2020 is probably the awareness that public space agency and also private space companies that have huge interest, in their assets in space
Mm,
start to have about the space debris removal needs.
mm,
This awareness has brought to fund is some forefront technological projects that will tackle space debris by removing one or more dead satellites, knowing that the problem is destined to get worse with the several thousands of pico nano satellites, such as CubeSat, that will be sent on orbit in the following 5 years.
mm.
Uh, think space tourism is also likely a breakthrough.
Right, yeah.
Predicted, in 2021, which should be finally the year in which the first commercial flight is to happen,
So exciting.
carried out by probably Blue Origin, New
Yeah.
Shepard vehicle, or uh, Spaceship Two or Virgin Galactic.
Mm,
Another breakthrough can be the launch of new space projects by funding some startups, like my company ShipNSpace is hoping to be part of. And in general, I think the growing perception that space investments in a pandemic era can really shift from building, unnecessary large passengers aircraft to more comfortable, controllable, and confined new space projects, such as building a permanent human outpost on the moon, an orbital hotel, or just suborbital
mm.
vehicles.
And, let's talk about ship in space some more. You've already mentioned it a couple of times. Can you explain your technology? What makes it
Yes,
unique?
I can. Well, the unicity of, for example, the 44 passenger suborbital vehicle is that our technology permits on one side to increase the overall performance, such as the number of passengers from
Mm-hmm.
the current 6 of New Shepard or Spaceship 2 to 44. And on the other, to increase the safety of the vehicle by permitting the passengers to survive at a possible explosion or other major contingency events by splitting the vehicle and save its precious payload.
Mm-hmm.
You see, normally safety is increased by designing components more robust with better materials, technology, and by increasing operational control. All
Mm-hmm.
this means obviously more cost, and very often it comes out that is not enough. When you see the failures of the space shuttle, despite the enormous cost, and the spaceship too, with the loss of a pilot and other tragic casualties. Uh, in my opinion, space tourism can become economically sustainable only if safety is increased at a level of a London, New York flight.
Mm-hmm.
And this can only be achieved if the design of the vehicle is inherently safer, which means monitoring structural anomalies during the flight and provide an automatic escaping scenario by splitting the vehicle and save the passenger's cabin.
Mm-hmm.
Our technology permits to do that without increasing the complexity of the structures. On the contrary, it rather to be simpler. To understand this, you can imagine that the traditional vehicles use brackets that rigidly fix the structural components, such as the cabin. These brackets work normally in tension, compression, bending, and sometimes also in torsion. In the ShipNSpace vehicle, the brackets of the passenger pods work only in compression. This
Mm-hmm.
means that at any time, the passenger pods can be let free by splitting the fairing that surrounds the pods. This permits an immediate escaping scenario, reducing at maximum the complexity of the systems,
Mm-hmm.
but also, which is fundamental, it reduces the level of vibrations, or what is called the amplification factor,
Mm-hmm.
the ratio between output and input acceleration. Reducing the level of vibration is essential to reduce the mass of its components and then increase the performance to mass ratio. This is why ShipNSpace has 44 passengers instead of 6,
Mm-hmm.
for example. Our unique technology has also permitted to design a heavy launcher, the LBL, which has the largest capacity ever, capable to send 58 metric tons of cargo to the moon surface, and based on one single booster type for 3 stages of the launcher, then the cheapest to develop,
Mm-hmm.
because based on one single engine and the booster structure. From this project, it has derived the design of a multitask logistic module, or MTLM, suitable to fly with current launchers such as Falcon 9 or Ariane 6, based on our LBL fourth stage design,
Mm-hmm.
and that is capable to accomplish a mission directly from low Earth orbit to the moon surface and send over 6 tons of cargo.
Mm-hmm.
Yes, ShipNSpace has designed, I think, the most advanced project for space tourism, for
Mm-hmm.
sending cargo to the moon
Yeah.
and build a permanent moon base, and recently also to remove space debris.
Wow.
Thanks to a technology that instead of moving debris to the atmosphere, something that loses the delta V, got to reach out to the debris, and
Mm-hmm.
so can be applied to just one single debris, will permit instead to annihilate the debris they are,
Mm-hmm.
by using powerful laser and using the sublimated fumes to create a thrust and reach out the next debris in a self-sustainable loop.
Mm-hmm.
Laser is used inside the vehicle in a pressurized container into which the debris is captured in such a way to provide a safe way to use it.
Mm-hmm.
Uh, these are basically our technology.
Incredible, absolutely incredible. And lastly, Let's talk about the future a little bit. I think space technology always seems very futuristic. And what do you think, or what can we expect from the future of space innovations?
Predicting the future is always difficult, but what I hope, I expect all this innovation and obviously the startup influence on space, on opening new space market. I expect them to provide probably a new point of view to people and governments by realizing that, well, by realizing that what happens outside our planet and how humans can interact with that can one day maybe save our planet from diseases and destruction.
Right. Mm.
You can imagine, for example, about a moon base with scientists, engineers, working on systems that can protect our planet from meteorites destined to impact Earth, for example, developing new drugs and still setting up new launch systems from the moon, operating directly from the moon and opening the way towards the colonization of other planets. This is what I hope we are going towards, because I'm rather worried of the fact that at the moment, let's say 98% of the business is concentrated in LEO and GEO, geostationary orbit, just focused on satellites. And I hope that we can understand that, orbital planes are not infinite, and there could be an issue for everybody if there is, for example, a collision between satellites on orbit. That would be catastrophic and probably cripple the whole of space business for decades. So before arriving to that, I hope that we can open our mind towards at least the moon.
All
That will permit it to set up new endeavors, new systems, and opening the way towards the colonization of other planets.
Wow, so exciting. We've reached the end of our podcast episode. Thank you so much for your insight, Fabrizio.
Yeah, thank you, Livia, for your invitation. It was very kind, and I hope to have given some comments that can be useful to someone.
You can read more at wagas-group.com. This has been your Innovation Talks podcast, produced by Livia van Herde. Make sure to check back next month for the latest insight in innovation.